Okay, stats, this is the last section of chapter 11 that we're going to talk about. This is kind of like, it goes with 11 too, but this is all analyzing contingency tables, which are also called two-way frequency tables. A little baby noises in the background. So two-way frequency tables, we're going to talk about and do two examples together, and then I'm going to have you do this one on your own for a homework problem. So should be kind of a short day, shouldn't be too terribly difficult, but this is the last thing in chapter 11, and then the next thing up is to start our final project, which will look like this big old packet. There's like 10 pages to it. And so we'll spend from now until you guys leave for graduation doing this stats packet, I guess. So here we go. Last day of regular stuff before we do that. Sister? There we go. Okay, so example 1. All right, they give us some data up here in the exam in the heading, and we may have done this same stuff already before in like algebra 2, but you know, that's something that one of the standards that we have to hit in statistics also, so I repeat it again, I guess. Two pieces of information. It gives me 2.5%, and then it gives me a 94%. Okay, so let's write down what those things mean. We're talking about pets here, and we have a Schnauzer breed of dog, and 2.5% of them are infected with a certain type of skin condition. So I'm going to say over here, I'm just going to take notes. Skin condition equals 2.5%. So it's typically thought that 2.5% of the entire population of Schnauzer breeds of dogs have this certain problem, okay, certain skin condition. Now, the 94% is going to reflect the accuracy of the test, okay? So I'm going to say test accuracy. Okay, test accuracy is 94%, which means that 94% of the dog, like 94% of the time, it's going to reflect accurate results on the test. So if I have a dog that has the skin condition and they come in 94% of the time, they will test positive. Okay, 6% of the time I might get dogs that test negative when they actually have the skin condition. Or if I have a dog that doesn't have the skin condition, 94% of the time they should test negative. 6% of the time they'll get a false positive. And we'll talk about that here in a second. So two different things. These two things are completely unrelated. A lot of people look at those and they're like, but they don't add up to be 100%. That's because they're testing for different things. This is reflecting who has it. This is reflecting the accuracy of the test. Two completely different things. They will not add up to be 100%. Or they might, but they shouldn't, okay? So I always start down in the very, very bottom of our two-way frequency table with 100,000. And I start with that number just because it's a really large number, and taking percentages of it makes it really super nice. And you shouldn't have any decimals and stuff in here if we start with a really large number, okay? So it doesn't really matter what number you start with down here, but I start with 100,000 to make it really nice. All right, two-way frequency table. Two-way. Let's talk about what we're talking about here. These two on the side have to do with whether they have the skin condition or not. So, like, do they legit have the skin condition? Then these two up here have to deal with like how they're testing. So, are they testing positive? Or are they testing negative for the skin condition? They do this stuff when they like talk about COVID results, because like if you have the skin condition, you should test positive. You should be in this category. But if you have the skin condition and you test negative, this would be a false negative. Don't write this in here. I'm going to erase this here in a second. So this is a false negative. If you don't have the skin condition, so there's no skin condition, you should test negative. So you should be in this category. But every once in a while, you'll have a false positive, which is kind of like with COVID, a lot of people were testing false positive because they would have like just the common cold or something like that when they would actually test positive for COVID. So that happens. And that's due to the fact that we have a test that's only 94% accurate, okay? That you will get false results. So typically, what should happen is we should have our largest numbers in these two categories, but every once in a while people will trickle into those two, okay? All right, so let's go and let's crunch some numbers here. And we are looking at, first of all, let's talk about has a skin condition and does not have skin condition, and figure out those totals from here, okay? So if 2.5% have the skin condition, okay? Now, first thing you're going to need to do is convert that to a decimal. Okay, 2.5% is not a decimal right now. We have to move it 2 decimal places, so we have 0.025. Okay, and then I want to use that to figure out who has the skin condition, or how many out of this 100,000. Okay, if I take 100,000 and I multiply by that 0.025, okay, this has 5 decimal places. So what I'm going to do is I'm going to move this 5 decimal places. So that gives me 2,500 that will have the skin condition. Okay, 2,500 out of there that has the skin condition. Then what I can do is, if 2.5% have it, then that means that 97.5% don't have it. So I could take this times the 100,000, or I could just subtract these two numbers, and subtraction might just be easier in that case. So this would be 97,500. And that is going to be the number that I have for that. Okay. Now we have to deal with the test results. And I've got to figure out where my calculator is. Give me just a second. Because some of this stuff I can't do in my head. Let's see. Hold on. Okay, here we go. So 94% accurate test means that 94% of the time, if you have the skin condition, you're going to test positive. So 94% of the time, you're going to get a result here. Same thing with here. 94% of the time, you should get a result that's negative if you don't have the skin condition. But 6% of the people are going to trickle into this category, and 6% are going to trickle into this category. Now, all we're going to do is we're going to take 94%, or 0.94, times this 2,500, and we're going to take 6% of 2,500. Okay, so let me do that real quick. All right, so 0.94, I'm figuring out this number right here. 0.94 times 2,500, this wouldn't be a bad idea for you to check this, is 2350. Now, again, I can take 0.06 times 2,500, or I could just subtract these two, whatever you want to do, it doesn't matter. This would be 150. Okay, so out of these 2,500, 150 are testing negative, and 2,350 are testing positive. Okay, now we do the same thing for the 97,500. 97,500. I'm going to take that times 0.94, and this number is 91,650. It doesn't matter which one you do first. And then I get 5850 over here for 6%, okay? Or you could, again, these two numbers should add up to be the third one, okay? All right, now that means total testing positive, if I add those two together, would mean that everybody who tests positive is 8,200 people, or 8,200 dogs, I guess I should say. If I add these two together, that is going to be like 91,800, I think, okay? Now, these should add up to be the 100,000. Okay, so this is how my table breaks down. And then from here, we can kind of crunch some numbers and come up with some results here. Okay, so let's do this. It says, find the probability of the skin condition given, circle that word or underline that word, given that the test result is positive. Okay, so we've dealt with givens before. These are something called conditional probabilities. Conditional, meaning that normally when we do a probability, we put our total on the bottom, and then we have who we want on the top. But that's not the case for a conditional probability. It's like limiting the total down to only a certain condition. Okay, so I'm going to say condition, and the condition is that they are positive. So I want just the positive people on the bottom here, and then I want the probability of the skin condition. So I want the probability of them having this skin condition out of the total number of positive people. So instead of doing 100,000 as my bottom number, my positive people are just the people who test positive. So people who test positive, or dogs who test positive, is 8,200. Okay, now of those, how many actually have the skin condition? Has a skin condition is the 2,350. Okay, now here's the deal. These ones are testing positive, like 8,200 are testing positive, but out of the ones who test positive, if I divide those, this comes out to 28.7%. Out of all of the dogs who are testing positive, only 28, almost 29% of them have the skin condition. That means that like 71% of the dogs who test positive don't actually have the, and 70, let's see, that would be 71.3%. 71.3% are actually don't have it when they test positive, or I'm going to say equals false positives. Okay, now, of those two numbers, which one's the majority? The majority is the 71%. So the majority of my positives are actually false positives. And 28.7% is like a true, positive, okay? So do you think it's a good idea for the vet to treat every dog that tests positive? I'm going to say no. The majority, 71.3%, in parentheses, are false positives. Out of all the positives that I get, the majority of them are false positives. Now, you could argue this and say, like, okay, if, the treatment of the dog is like really non-invasive and not very bad for them, like if it's just like a $5 ointment that I put on their skin, you might as well go ahead and treat them if it's not going to hurt them, like what's the harm in that? But if it's going to be like $1,000, injection that they have to get, whatever, and it's going to cost me a lot of money and be really painful for the dog to get, you better believe I'm going to run that test again. I'm going to say, test them again for the skin condition to make sure that that result is not a false positive. Because when you test them again, the chances of getting 2 false positives in a row go down significantly. Okay. So that's kind of how that works. Okay. All right. Number 2, same thing, but they don't have kind of a step-by-step A/B for us to fill in. They, ask us this question at the end, okay? So underline that question. That's what you're trying to answer, okay? So here we go. Let's pull out the 2 pieces of information that we need. We're talking about watches. Let's do this. Yeah. Okay, watches. We have a 0.05% of watches are defective. So defective equals 0.05%. Now, even though that's a decimal, that's actually a percentage, which means we don't look at 0.05. We're actually moving the decimal 2 places this way. So that's 0.0005 is the number that we're going to use when we multiply. So maybe put a little star by that we're going to use that percentage actually instead. Okay, now our test effectiveness, our test accuracy is only, well, it's better. It's 98% now this time, which is 0.98 is the number that we're going to use. Okay, so, all right, and what's happening is we have watches that are coming through this assembly line. Some of them are defective, and we have a 98% test that's going to tell me whether they're defective or not. Okay, so I'm testing all these watches. 98% is not a bad percentage for accuracy, but we'll see what it does when we crunch the numbers. I start with 100,000, and what they're doing is the engineer tests some of the watches and discards any of them. So like if they show that they're defective, he's just going to toss them out. Some of those are going to actually be working functional watches. And so we're going to crunch those numbers and see how many that actually is. But here we go. Let's do the defective ones. So 0.0005, if I take that times 100,000, again, this is 5 decimal places. So I'm going to go 1, 2, 3, 4, 5. That's 50 watches are defective. Okay, 50 watches are defective. So 50 is going to go right here. Now, if I subtract those 2, or you could, like figure out the other percentage and multiply, this is 9,950. So 99,950 are going to be non-defective watches total. Okay. All right. Now we have a 98% accuracy test. So 98% of the time, if they are defective, should they end up here or should they end up here? If they're defective, then the test should show defective, right? So they should end up here. This is 98%. Okay. 2% of the time, they're going to have a false, what would that be? A false positive or false negative. I guess false negative. So 2% of the time they're going to do that, okay? If they are not defective, they should test that they're not defective. So 98% of the time they're going to do this. 2% of the time they're going to do this, okay? All right, and I'm going to do those percentages to this number. If I take 0.98 times 50, or 98% of 50, that is 49, and 2% of 50 is 1. So those two numbers add up to be 50, okay? Now I got to get my calculator out. Let's do 98%. I'm going to do this one next. 98% of 0.98 times then 99950, and that is 97,951, and this one is 1999. Okay, so there's how those numbers break down. Oop, I put my comma in the wrong spot. So this would be 97, 952 total, if I add those together. And this should be like 2048, I think, 2048. And if you add these two together, then it should be your entire 100,000. Okay, so let's look at, if we're talking defective, let's talk defective here. Out of all of the 100,000 watches, 20,000 or 2,048 are going to be defective. Okay, all right, so like positive for defect, let's say 2048 is my bottom, but out of those, only 49 of them are actually defective. Actual defective. Okay, so if I'm looking at that as a percentage, 49 out of the 2048 is going to give me 0.024, let's say, which is 2.4%, which means that all of the watches that are testing to be defective, out of all of the watches, only 2.4% are actually defective, which means that 97.6% of the watches are testing that they're defective when they are not. These are all my false positives. Okay, that means 97% or almost 98% are getting thrown out for no reason. Like 97% of the watches that get tossed. These are all the watches that are getting tossed. Okay, all 2,000 of those watches are going to get tossed, but these are the only watches that should have. That means that these watches should not have gotten tossed, okay? So we're wasting a lot of money, okay? Let's go back up to the question. Do you think it's a good decision for them to discard any of the ones that show to be defective? No. Don't discard defective watches. 97.6% of them are actually working, which means we're wasting a lot of money if we discard them. Okay, so that's kind of how that breaks down. Now you don't have to like go through and use the same terminology that I do, but do in your homework problem down below here, do provide me some sort of like, don't just say yes or no, it's a good decision, bad decision. Give me some supportive. So you can either come at it from the 2.4% standpoint or the 97.6% standpoint. I don't care which batch of data you break down and give to me, but just give me something so that I know you didn't just say yes or no and call it a day. Okay, you have to give me a little bit of backup. All right, so what's the alternative to not just discarding the watches? Run the test again, okay? I use this example all the time. J.C. Himmelberg, which would be like Jalen Himmelberg's older brother. He knows that I talk about him all the time when this happens. When he was in 7th grade, which would have been in like the spring of 2013, I think that was when I was student teaching, maybe. It's been a long time ago. He was tested. He had some health issues going on and was tested. His blood was tested. And they found out that he had cancer. As a 7th grader. He had some sort of a blood cancer. They thought maybe leukemia and stuff. So he tested positive for cancer. Rather than them going through all the procedures and running the chemo through his body and making him very sick and, you know, doing all that stuff, they do a second round just to test and make sure and make sure that it's positive. I'm sure they did the same thing to little Ryder arms. They run all those tests again just to make sure before we try to pump you full of all these chemotherapy treatments and stuff, you know, which ultimately will hopefully make you better, but it will make you very sick in the meantime. Rather than doing that, let's run the test again, and it turns out that JC had some form of a strep virus that was causing it to run a false positive for leukemia. So that was a very good outcome from that situation, but that's just goes to show you how often that happens. I mean, it's even though the test is 98% effective or however effective, you still will get a huge batch of people in there that are getting false positives back. It was very common in COVID. You know, even though they have a really accurate test, it happens. So breaking down these numbers can kind of show you that, like, even though your test is very, very effective, it's not going to be foolproof. So go through and make sure you give me some sort of an explanation on number 3 when you go through and do that one. And ultimately, do you think it's a good decision is what you're trying to say. But give me a nice, good sentence backed up with some information. And start with 100,000 in the bottom corner. And there you go.